Okay, this is Mr. Precella with his college algebra class, and today we're going to be discussing lines. Actually, we're continuing a discussion of lines. We graphed lines last time, at least we had two lines. We graphed a lot of things the last time. Some square root equation, what were the names of those things? Absolute value curve, 3-point quadratic, and I'm missing one. Was it 4-point cubic, if I'm remembering correctly? So we graphed a lot of things with exponents and some without. If there's not an exponent on the x or y, then the graph of the equation is a line. If we had something like ax plus by equals c, that's standard form for the equation of a line. There's no exponent on the x or y. The a, b, and c are just numbers. And if there's both an x and a y in the equation, then that graph is a slanted line, like the ones that we did the last time. Oops, it's a slanted or diagonal line. If there's only one variable in the equation, either an x or a y, there's only one variable in the equation, the line is not slanted. So by not slanted, well, that means it's either horizontal or vertical. That's what I mean by not slanted. It's either a horizontal line or a vertical line. And the ones we did the last time had x's and y's in it. And so they were slanted lines. A little terminology. If you have a line, we draw with a line. Assume this is the x-axis and y-axis. The point at which the graph crosses the x-axis is called the x-intercept. I believe I may have already mentioned that before. The x-intercept is that point where the graph crosses the x-axis, where the graph crosses the x-axis. And similarly, if you've seen that definition, you can figure out right there. There's the x-intercept. The y-intercept is where the graph crosses the y-axis. I have this strange sense of deja vu, like I've already said that today. And it's a joke that no one in this class got, but the people watching the video won't know what the heck I mean by that. Okay, where the line crosses the y-axis. We had just defined these a few moments ago in class, so I'm writing it out again. X-intercept, y-intercept. And maybe we need to do a problem. I've printed out the homework problems on my math lab that we're going to be doing. And I think I've done that before this semester, the way you can print it out, work it out on paper, and then just punch in the answers real quickly. Okay, so let's look at problem number 1. This is our first example. Let's see if it's going to be a hard one or an easy one. It says, find the coordinates of the y-intercept and of the x-intercept for the line displayed on the right. Ooh. Can y'all tell that? Let's see. It says, the first thing it asks for is the y-intercept. So let me put a big dot where the graph is crossing the y-axis. It's sort of hard to tell, isn't it? Would it be right here? Yeah. And those of you with the good eyesight, what does that look like? 4. So I'm going to have to type an ordered pair. 0, 4. Now, be sure when you type this in on My Math Lab that you're putting those parentheses there. Okay? So 0, 4 is the y-intercept. And what about the x? I'll do that in blue. Would be right here. Does that look like a... I was thinking it's a 1. Okay, 1, 2, 3, 4, 5, 6. I could do a physical zoom by lifting it up.
That's definitely 1.
Yeah. So, let's see. What am I going to type in here? Parentheses and 1, comma 0. Okay. Now, in algebra, you always do it one way, then you do it in reverse. So here we've looked at the graph, found the intercepts. Now let's go backwards. Suppose you were given the equation and asked to find the intercepts and then graph the line. Okay? So that's so small, I'm going to write it out. The equation is x minus 2y equals 2. How the heck would we find those intercepts? Let's look at those intercepts right here. Both of them have 0. One of them has 0 for the x and the other has 0 for the y. So that tells us if we want to find the intercepts, fill in the table that we were doing in the last assignment. I reviewed that before class, or before I started this. Do what we did right here. Plug a 0 in for x, figure out y, then plug a 0 in for y, figure out x. That's what the intercepts look like. The x and y intercepts are going to be things that have a 0 in them. Okay? So let's plug a 0 in for x. If I put a 0 in for x, I would have just 0 minus 2y equals 2. And what would y'all do to solve for y here? Y'all divide by -2 to get y equals -1. And this assignment, I decided since I was going to be making the video and I didn't want to have to do a separate video on using the tools, I only assigned the multiple choice problems for graphing. Sheer laziness on my part. Now, what about the other one? If I plug a 0 in for y, is that going to be hard or not that bad? If I plug a 0 in for y, I'd have x minus 2 times 0. 2 times 0 is 0 equals, is it just x equal 2? Well, sure would have been nice if I'd had some graph paper. I intended to bring some, but I forgot. So I'm actually going to go through and graph it. When you're doing it, you might just want to look at the A, B, C, D. Okay, but since these are the graphs here are so small, I'll first graph it, and then we'll look at the choices and see which one it is. Over 0, down 1. That first point, that's the y-intercept, isn't it? Okay. Over 0, down 1. Right 2 up 0 is the x-intercept. So there's the line. Oh heck, you know what just dawned on me? I guess y'all don't even need to graph it. Look at this. This is a problem with two-part multiple choice questions. It asks find the intercepts and then graph it. Once I found the intercepts, do we know what the graph is? Let's see, which one? There's only one of them that has 0, -1, and 2, 0. Which one is it? A, B, C, or D? Can y'all tell that? D. And there the graph. That's the problem with printing them out on paper like this. You can't zoom in or blow it up like you can on My Math Lab when you're actually online doing it. But this one is a D. Now, as soon as you knew those intercepts, 0, -1, and 2, 0, then it's got to be that graph. But at least you saw that graph. Now, a little word about vertical and horizontal lines. Okay? Those are the lines whose equation have only one variable. If there's two variables, then it's a slanted line. If there's only one variable, let me see this so that isn't shown. If there's only one variable, it's either vertical or horizontal. So if you have an equation and horizontal lines. If you have an equation in the form x equals some number, it's not a slanted line. It's either vertical or horizontal. So, what is it? Well, it's crossing through this axis at that number. Okay? It's a line that passes through the x-axis at this number. If we wanted to graph x equals 2. Suppose we were graphing x equals 2. You don't have to do this stuff here. You don't have to plug any numbers in. If there's only one variable, then here's how I think about it. Oh, please tell me that's not my phone. I think I forgot to turn it off or to silence it. Oh, dear. Okay. Oh. Now, how to make a good first impression or second impression by Mr. Precella. Okay. What sort of line? Picture one. It's passing through the x-axis at the number 2. So, there's the number 2. It's going to pass through the x-axis. The horizontal one's the x-axis. So, what sort of line is this going to be? A vertical line or a horizontal line?
Vertical.
It's a vertical line. There it is. A lot of times students start thinking if it says x equals, it's horizontal because the x-axis is horizontal. No, no, no. Every point on this line, if we were going to label ordered pairs, like right here, this is the point 2, 1, 2, 2, 2, 3, and so forth. Every point on this vertical line has an x value of 2. It's cutting through this axis at this number. Okay, so if it's an equation in the form x equals a number, it's a vertical line, not a horizontal. Let's make a note of that. X equals number is a vertical line. Having said that, I bet you can figure out what y equals a number is. Well, what sort of graph would pass through the y-axis? Well, it'd have to be a horizontal line. So it might be exactly the opposite of what you think. Because x-axis is horizontal, but x equals a number, that's vertical. Let's see. You know what? I think I've already done this problem here. It says graph x equals 2. Can y'all see that? Well, when I see this, I think to myself, I need a graph that cuts through this axis at the number 2. Well, okay, so if it's cutting through the x-axis, it has to be vertical. So if I were going to guess, I wouldn't guess B and C. Those are horizontal. Which one do y'all think it is, A or D? A. Let's do one with a Y in it, and I think it's a bit more involved. In order to graph an vertical or horizontal line, it has to be in the form x equals a number or y equals a number. The natural question is, suppose it isn't. Problem number 4, we're graphing y plus 2 equals 0. Graph y plus 2 equals 0. Well, it's either a vertical or horizontal line. How do I know that? There's only one variable. If it were x's and y's, it'd be a slanted line. And how would I graph a slanted line? Well, this, like we did the last time. What do we do? I mean, what am I going to need to do here? I need to move that 2 over and write it in the form y equals. Now I'm ready to decide what the graph looks like. It passes through the y-axis at the number -2. So those are so small, I'm going to go ahead and write it out. Okay, so it's passing through the y-axis at -2. Is that right there? -2 on the y-axis?
Yes.
So just extend that little mark that's there. Okay. Y equals -2. A, B, C, or D? Which one is it?
C.
Oh, I'm thinking it's A. I need to do a physical zoom. It's sort of hard to tell. Okay, because it's hard to tell with the way it's being colored or distorted up there. But the x and y axis have the arrows on them. So, and these scales are 6 to -6. That's what those 6s are. So I'm thinking it's A. C is what? Vertical or horizontal?
The x-axis.
Let's see. Wait. Which ones are vertical and which ones are horizontal? Can y'all tell? I'm thinking that B and C are vertical. A and D are the horizontal ones. Okay. When you're doing it on your own, you can zoom in the graph and it looks better. But right now you have the disadvantage of this little bitty graphs here printed out, and not having to try to zoom it physically. Okay. Any questions over graphing a vertical or horizontal line? And how do you spot a vertical and horizontal line? How does this equation look different from a slanted one? Slanted ones have x's and y's. Vertical and horizontal have only one variable, either x or y, not both. Now, now we're going to discuss something called the slope of a line. slope. The slope of a line measures the steepness of the line. Another way you'll see it stated is it measures how fast the line is changing, the rate of change. Slope is denoted with the lowercase m, not with the s. It's a lowercase m that's usually used to denote the slope of a line. And there's basically four shapes that a line can take. It could be slanting upward to the right or downward, and that's the only way that's the only way a slanted line can look. Either it's slanting upward to the right or downward to the right. If it's slanting upward to the right, it has a positive slope. If the line is slanting downward to the right, the slope is negative. Now, what about the two special cases? If you have a horizontal line, then it's flat. There's no steepness at all. Its slope is 0. Okay. A vertical line has a slope that's undefined. It can't get any steeper than that. If we were going to actually say something other than undefined, you might say infinity, but what we usually say is just undefined. And I'll show why that is when I actually state the slope formula in a little bit. Okay? So, in general, slope, I started doing it, didn't I? I was going to be trying to write out the word slope, but I knew eventually I'd start using the letter M because that's the abbreviation for slope. That's why I told y'all right off it's denoted M. Okay? Slope, there's two ways we can define it. Geometrically, we'll say it's rise over run. What the heck does that mean? Okay. Slope is rise over run. Oh, and here's one of these. You know what? I'm going to draw out a graph. I'm going to draw a slanted line here. Let's suppose it's passing through the origin right there. And maybe it's passing through this point right here. Oh, there. So I've drawn a slanted line. Now I'm going to try to illustrate what the heck I mean by rise over run. If I start at this bottom point, in order to get to this other point that I have here, how am I going to move? You go through the vertical movement, that's what it means rise, and then the horizontal movement. In words, how would I move from this point to this point? Up to and up to. I'm going to write RT for right 3. since both of those are positive, up and right, excuse me, these are up and right to both positive, the slope is 2/3. That coincides with what I said here. A line that's slanting upward to the right has positive slope. Now, let's try to do this one here. Well, it's a little bit bigger, but I still might need to zoom it in. It says, find the slope of the line shown on the graph to the right. Oops. Oh, wow. It's hard to even tell where the points are. This thing is scaled from -8 to +8. And there's a point here and here. Okay? Hard to tell. That's the downside to doing this stuff with paper. If I want to start at that bottom point, this one right here, and I want to move up to this one, do the vertical first, okay? How would I move to go from here to there? I would move up one and then, okay, over right or left? Up one, over, left one. So this would be 1, positive 1 because of up. What do y'all think I'm going to do here because of left? Negative 1. 1 divided by -1 is -1. So the slope of this line is -1. That rise over run. Okay. That's how you calculate slope geometrically. Well, how do we calculate the slope if the graph isn't given? Like on this one. Problem number 6. Find the slope of the line, and it doesn't give you the line. It's just giving you 2 random points. Well, one way you could do it is get out your graph paper, plot both of these points, and count rise over run. Okay, there's certainly nothing wrong with that, but you really wouldn't want to do that if these numbers were really large. Suppose instead of a 9, you had a 90. You don't want to be counting rise over run. So, here is the slope formula. And it's what we'll use here on problem number 6, 7, well, the next 3 problems I'm going to do. If we want to calculate the slope, and we're just given 2 ordered pairs, it's second y minus first y. That's getting you the rise over second x minus first x. That'll get you the run. We're given 2 ordered pairs. In order to find the slope, you can either graph them and count it out, rise over run, if you have graph paper, or second y minus first y over second x minus first x. Remember what these little subscripts mean. This is not y squared. It's not x squared. Let me write this problem a little bit bigger. The points are 9, 2, and 10, 4. 9, 2, and 10, 4. Remember what those subscripts mean. First x, first y, second x, second y. So I'll just plug it in. M equals, there's a minus in the middle, This first one here, there's no negative signs on the numbers. If there's negative signs, you got to be careful. Make sure you're keeping track. Because minus a negative will become plus, just like we were doing yesterday with the distance formula, or whenever the last class meeting was. Let's see. What am I going to write up here on top? It's y2, blue minus from the formula, y1, over x2, blue minus from the formula, x1. Oh, this simplifies nice, doesn't it? 4 minus 2 is 2. 10 minus 9 is 1. The slope of this line is a positive 2. You might have noticed the way it gives us this undefined option. Here's something we've said already this semester, but let's remember it. When is a fraction undefined? When we have what number in the bottom?
0.
A 0. So if we had gotten a 0 in the bottom, we would have said undefined slope. And if you get an undefined slope, and if you actually graph the line out, it'll be vertical. Okay? I'm not sure if we'll see any of that, but let's see. Let's do another one of these. Same type of problem. It says, find the slope of the line containing these 2 points. 3, 0, and 8, 1. Okay? Just writing it larger. Well, I'm going to go ahead and label each ordered pair. Make sure when you label these ordered pairs, you're going x, y, not x, x, or y, y. This is x1, y1. A common mistake students will make is they'll say x1, x2. No, no, ordered pairs are x, y. Second x, second y. Now let me go ahead and write out the formula. It's y2 minus y1 over x2 minus x1. So let's see. Be careful. y2 is 1. y2 is 1. y1 is 0 over, what am I going to have on the bottom? Can y'all see that? 8 minus from the formula, 3. I think this is just going to be a fraction, isn't it? What are we going to have? 1 over 5? Any questions there? Well, let's do another one of those. Same type of problem. I assigned 3 because I'm hoping at least one of them will wind up with some negatives in it for you. So here are my points. -2, 4, and 3, 0. Finally we have a negative in here. So slope is y2 minus y1 over x2 minus x1. I'm going to go ahead and label the ordered pairs. x1, y1, x2, y2. First x, first y, second x, second y. Let me see. Y'all caught up with me? Are there any questions? Oh, very silent today. So y2 minus y1 over, oh, let's be careful, x2. This minus, you may not be able to tell up there on the projector that it's a purple negative. And I'm about to put another negative. The green one, -2. So up on the bottom, we have a -3 minus a -2. Do y'all agree that's going to be a, yeah, so 3 plus 2. In the bottom, we have a 5. What do we have on the top? -4. -4 over 5. Okay. Any questions? That's how to find the slope when you're given two ordered pairs. Okay. I guess you could always just plot the two and do the counting, rise over run. Okay? But I'm doing the little formula instead. Just watch out for those minus negatives when that happens. Okay? You have 3 of these in the assignment, so surely in at least one of them there's going to be some negative numbers in it. Okay? Now, let me see. Clear this right. And when we began all of this, I said the equation of a line has no exponents in it, and if there's both x and y, then they're slanted lines. Okay? If the equation is written with the x and the y on the same side, that's just standard form for a line, but there's another way you can write the equation of a line. The equation of a line can be written like this. Something called Slope-Intercept Form. Slope-Intercept Form. Slope-Intercept Form has the y by itself. If you algebraically rewrite the equation so that the y is by itself, that's called slope-intercept form. Why is it called that? Well, if you have the y by itself, this coefficient on x is the slope of the line. This other number over here we're calling a b, together with the sign, that gives you the y-intercept. The y-intercept is where the graph crosses the y-axis, and on a y-intercept, the x-coordinate is 0. It's crossing the y-axis. So 0, comma, whatever this number is, b, that would be the y-intercept. We write those y-intercepts as ordered pairs. Going back to that very first stuff we did. We didn't say the y-intercept was 4. You write it as over 0 up 4. Okay? So let's look at problem number 9. On problem number 9, we have the equation y equals -7/8 x plus 8. I'm just writing it larger. And the instructions say find the slope and the y-intercept. There are some problems you may have noticed in the homework where you write the problem down and then you got to scribble, work it out to get the answer. Is this one of those that you got to scribble and try to get the answer? Or is there not a lot of writing to it on this one? Is this one where we can find the answer pretty easily? If it's with the y by itself, if you have the y by itself, that number attached in front of the x, that's the slope. Negative 7/8 is the slope. This number over here is where the graph is crossing the y-axis. It's the y-intercept, but the y-intercept should be written as an ordered pair, and it's already done for you like that. It says parentheses, it might be hard to tell that, parentheses 0, comma, positive 8. The reason I circled this sign right here in front of the B is if it had been a minus 8 here, then you'd say the y-intercept is at negative 8. Okay? So there's the slope. I'll write out the word. The y-intercept is 0, 8. And it's already written with a 0 in front there. But I'm not sure if they're all going to have that 0 already written for you. What about, are y'all caught up? Any questions? Let's do problem 10. Easy or hard? Let's see. We're given the equation y equals 1/4 x plus 5. Well, I guess it's easy provided you know how to do it, okay? If you recognize that as slope, is it in slope-intercept form? Yeah. So what number am I going to say is the slope? 1/4. Very good. Now here you got to be careful. You're not just going to write a 5 there. Okay? You got to write it as an ordered pair. If it's crossing the y-axis at 5, what would that ordered pair be? It would be 0, 5. That's why I'm saying for the y-intercept, if it asks for that, you've got to make sure that there's that parentheses 0, comma. Here on this first one, I was breaking it to you gently. It had already put the parentheses in the 0, comma. But on this next one, you had to type in the parentheses and the 0, comma. And you're probably sitting there thinking, oh, wow, does he think that's hard, typing in the parentheses and the 0, comma? Well, no, but, you know, the common mistake. If you're just going to put a 5 there, punch it into my math lab, and it'll say wrong. Hopefully, it'll say the y-intercept should be an ordered pair as a hint to you, okay? But you get more than one guess on that. Let's see, is there another one like this? Oh, it's going to be a little bit harder. It's pretty easy to find the slope and the y-intercept if it's written with the y by itself. The natural question is, what the heck do we do if the y isn't by itself? This is problem. For all of you sitting out here right now listening, this is your problem number 11. Okay? But people watching it in the future, maybe it won't be number 11. Who knows? Okay? But for this right now, this is your number 11. How do we find the slope and the y-intercept? Well, what am I going to need to do here? We know how to find the slope and y-intercept if it's written with the y by itself. So what am I trying to say? Yeah, get the y by itself. What do I need to do to get that y by itself? Yeah, let's subtract 7x. And I'm going to write it as y equals, I'm going to write it with the x first. Slope-intercept form, always the general form, mx plus b. Always writes the x first. Negative 7x plus 9. Now that I've written it with the x by itself, is it not that bad anymore? What's the slope going to be? Negative 7. Did y'all hear that? The slope is negative 7. So negative 7. And the y-intercept is going to be, I don't just write 9, do I? But I have to do that 0, 9. A little of my history. When I was a student way back, those y-intercepts were numbers. Then somehow along the way, by that I mean you didn't have to write, it'd say the y-intercept is blank, and you'd say the number 9. By around the late 80s, all the books started, they decided it would be easier for students if they said it was an ordered pair. And I remember at the time saying, well, that doesn't make sense because then it's not really slope-intercept form because it's not an ordered pair. But that's what happened. So you got to write the 0, 9 now. Supposedly someone decided that would really make it easier for y'all. So. Oh gosh. Are we ready to do one more like this before we take a break? A very well-deserved break. Let's see. Find the slope and the y-intercept of the line whose equation is given. 12x plus 3y equals 6. I'll write it bigger. And we know how to find the slope and the y-intercept if the y's by itself. So what am I going to do? Get that y by itself. It's going to take a little bit more effort on this one. Look at what we'll have to do. We'll subtract the 12x. So we have 3y equals negative 12x plus 6. And unlike the one we had done just a moment ago, where once you move the 7x, the y is already by itself, on this one we have the number 3 we need to get rid of. What will get rid of that? Divide by 3. Just go straight through dividing by 3. And what are we getting? Y equals, is that a negative 4x? Plus what? 2? Okay. Are we now ready to fill in the blanks? What's the slope and what's the y-intercept? Slope, is it going to be negative 4? And the y-intercept is, okay, did y'all hear that? 0, 2. Okay. 40 years ago, you would have just written a 2 there. None of those 0, that was before my time. I was not studying algebra 40 years ago. But, so, any questions there? I think we'll take a short break and then we'll come back and finish this discussion of lines up. Okay, there's only 3 more problems to go. I guess we could just keep going and finish it up. But no, we'll take our break now, okay? So I'll see you back in a little bit. Thanks for listening.